Developers today can type a loose conversational prompt and watch a fully functioning application manifest in seconds. We call this vibe coding. When you can generate thousands of lines of syntax instantly, traditional manual programming feels like using a typewriter. It creates an intoxicating illusion that the software is finished the moment it compiles. But there is a structural flaw in this workflow. Large language models are highly efficient pattern matchers, but they are terrible mind readers. If you prompt an AI to simply add photo sharing, you force the model to guess. It has to invent its own unstated assumptions about your database architecture, maximum file sizes, and user permission hierarchies. Vibe coding outsources critical architectural decisions to an entity that possesses zero context about your actual business goals. Left unchecked at an enterprise scale, those unstated AI assumptions mutate into what the industry calls a markdown monster, a codebase that appears functional on the surface but is structurally hollow underneath. Because the AI optimizes for output rather than security, it reliably hardcodes invisible vulnerabilities into the system. It will happily concatenate user inputs into SQL strings, or bypass secure authentication protocols just to make the feature work. And when you try to fix it, the problem compounds. Tweaking a loose prompt to patch one bug often triggers silent regressions, inadvertently breaking 3 prior working features elsewhere in the application. You end up with blindingly fast code generation, agonizingly slow debugging, and a complete loss of version control over the system's underlying logic. The volume of code being produced vastly outpaces the physical capacity of human developers to review every line for subtle logical errors. Generating syntax at high speeds without strict intent alignment does not accelerate product development. It only accelerates the accumulation of technical debt and critical security risks. To solve this chaos, the industry is adopting a structural methodology called Spec-Driven Development. The methodology operates on a counterintuitive rule. If you want to build software reliably with AI, you have to stop writing code and start writing strict machine-readable specifications. On the left, a conversational prompt is fuzzy and unstructured, leading to chaotic outputs. On the right, a spec acts as a deterministic contract. A constitution layer is applied, actively blocking vulnerabilities and ensuring only secure operations pass through. This creates a strict division of labor. Humans define the what, the business logic, and the constraints, like the security rules. The AI is strictly relegated to the how, the syntax typing. By shifting from conversational instructions to engineered contracts, you strip the AI of its ability to make dangerous assumptions. You guarantee secure outcomes by design, rather than hoping for them by chance. This changes the day-to-day reality of debugging. In the vibe coding workflow, when a developer spots an error, they open the file and manually edit the AI-generated syntax to fix the bug. Spec-Driven Development issues an absolute mandate. If there is a bug, you never manually touch the code. Because code generation is instantaneous, any human patch will simply be overwritten. Instead, you update the spec document, bypassing the code entirely, and let the AI regenerate the solution flawlessly. Treating code as a precious, handcrafted artifact is an obsolete mindset. Code is now a highly disposable, derivative byproduct. If the code is wrong, it means the spec was wrong. The specification, not the syntax, is the ultimate source of truth in the system. This shift moves the developer's focus away from the keyboard and toward the system diagram. Developers are transitioning away from being manual laborers of syntax. They are becoming high-level orchestrators of AI swarms and architectural reviewers. The core skill is no longer memorizing the idiosyncrasies of specific programming languages. The value lies entirely in articulating intent and defining constraints with absolute clarity. In an environment where autonomous agents can instantly build anything you ask for, the ability to manage context and enforce rules is vastly more critical than the ability to write scripts. For decades, the physical code was king. Design documents and requirements were often treated as afterthoughts that drifted out of sync with the application. In an AI-native world, the physical code is no longer the primary artifact of software engineering. Human intent, when formalized into a strict, machine-readable specification, is the actual, durable product being built. The formalized specification is the new source code. The syntax is simply the byproduct of a successful compilation.